In this chapter, we're going to continue talking about multiple regression. Now, for most of this course, really, but particularly it's pertinent for the last chapter and this chapter, we have been focusing on quantitative variables. So we've been using quantitative variables, numerical variables, in our simple linear regression and our multiple regression. If we think about the model that we have been working with up to this point, the one where we are estimating hourly wages, the independent variables we're using are quantitative, right? Years of experience, years of education, those are both quantitative variables. However, sometimes there are categorical variables that have some explanatory power for what we're looking at, right? That a categorical variable will tell us something about our dependent variable. So how do we add those into our model? Now, we do have to take a little bit of time to think about this question because, of course, we can't just put that data in and plug it into the normal method because it's categorical. So in the kind of the extreme case for categorical, we're talking about nominal level data where we just have labels, descriptions, and we can't enter that into an equation, right? Even though we didn't cover how to mathematically estimate a multiple regression, we can think back to our simple linear regression. We've got those formulas for B0 and B1, and we need numbers to calculate those values. All right, so how are we going to do this? Well, what we're going to do is we're going to use what is known as a dummy variable. All right, dummy variables are also known as indicator variables, although I prefer dummy variables, this is what I'm used to, but they're called the same thing. So indicator variable, dummy variable, those are the same. So the way that these dummy variables work is we're going to assign one value of our categorical variable to be 1 and the other to be 0. So if we have a dummy variable, let's say, we'll just call it for simplicity's sake, we'll say x is our dummy variable. The way we'll set these up is like this. So x equals 1 if, and then whatever criteria we want to set, and 0 if otherwise, essentially just if it's anything but this criteria we have set, then it's going to be something else. Or excuse me, if it's anything other than the criteria we set for the variable to be 1, then it's going to be 0. So let's actually illustrate this real quick. So let's go back to this idea of wage, right? If we're trying to predict hourly wage, there are some categorical variables that are very common in a lot of econometric models that we might want to include here, right? We might not just want information on a person's education or their experience level. We might also want some information on things like race or their sex, right? So we might include some variables for those. So we're going to include two dummy variables. The first one we're going to include is what we're going to call female. All right, so the variable female is going to be coded as 1 if the individual is female and 0 if otherwise. This will hopefully give us the effect on wages from an individual being female. And it's really going to tell us this idea of difference in wages based on sex in general, but this is how we're going to set that up. Right, most of the time, as we might can see from this, when we create a dummy variable, whatever we're going to tag as 1, we also kind of just make that the variable name, or some variation of that would become the variable name. You know, if it's really long, you want to condense it, but again, that variable name is often going to represent what 1 equals. Right? We also might want to include a measure for race, right? A race variable. So we are going to use the variable black. All right. We can probably figure out how this is going to be coded. All right. Black. The variable black will equal 1 if the individual is black, and 0 if otherwise. All right, so again, this is going to give us an idea, right, or at least allow us to attempt to estimate the effect of being female on wages and the effect of being black on wages. So now so that's how we would set those up. Let's now include those in our model and then look at the estimated regression equation. So we're going to just pop these right into the model that we have been working with. We can save that for later. So this would be our model, right? Wage I equals beta naught plus beta 1 times education I plus beta 2 times experience I plus beta 3 times female I, beta 4 times black I plus our error term. Right? So that's our model. Not going to leave it up here for too long, but once we've got this model stated, we've kind of shown how we're going to include these variables into our model itself. Now let's look at the estimated equation. So before we get into actually looking at these categorical variables, once again, I just want us to just run through the model, just point out some differences between the estimated equation and the model itself. Right, so remember that when we've got the estimated equation, right, we're no longer looking at wage I, because wage I is the observed value. We're now looking at the predicted value, so this will be wage I hat. Also, remember that error term that we have in the model drops off when we get to the estimated equation. All right. Now that we had kind of gone over that, let's look at these variables. So the way that we interpret a dummy variable is slightly different from the way that we're going to interpret a variable that has a quantitative variable, right? The coefficient attached to a quantitative variable, I should say, I guess, right? With those quantitative variables, right, we can have that kind of the way we've interpreted is a 1 unit increase in our independent variable leads to a beta or b whatever unit increase in the dependent variable, right? But with our dummy variables, we don't have 1 unit increases. right? There's not a progression. It's either 1 or it's 0, right? There are only 2 options. So what we're going to do is we are going to use, right, kind of the way we're going to interpret this is that this is the difference. It'll be the difference between whatever group the group is that we tied to 1, or whatever we've defined as being 1, right? It's the difference between that and 0. All right, so 0, we're going to talk a little bit more about this. Whatever we're leaving out, right? Because if we go to female, this would, in an econometric model, this would normally be a binary variable, male or female, would be the responses to this, and then you would code it as female, right? So really we could break this up into 2 kind of groups, male and female. We're leaving out male, so that's what's going to be 0. So we're looking at the differences between hourly wages between female and males, right? That would be the kind of the idea when we're including something like this in our model. Same thing goes for our black variable. This one's not so much a, if we're just saying race in general, that's not as much of a binary variable, at least in econometric models, but when we get to it, for simplicity's sake, often we just kind of condense that. So this would be, the difference between an individual who's black and anyone who's not black, right? So that would cover any other kind of racial or ethnic groups. Or I guess ethnicity's separate from race, although people don't always acknowledge that. But regardless. So again, the point of this was when we're interpreting these dummy variables, we're going to reference, right, the other group, right, whatever's left out, known as sometimes the base level variable, the reference group. Again, we're going to talk more about that when we look at the next thing. All right, but so for example, if we're interpreting beta 3, right, the coefficient, or B3, the coefficient associated with our variable female, right, it's negative 4.516. Actually, I'm just going to write this up here. Oop. All right, so beta 3, it's not, I keep saying that and almost wrote it. This is not beta 3, right? This is the estimate of beta 3, right? So B3 equals negative 4.516. So the way we could interpret this is, again, kind of going by that idea of ceteris paribus, all else equal, so the only difference being changes in the variable associated with this coefficient, right? I would expect a person who is female to have hourly wages that are $4.52 lower than a person that is male, or a person that is not female, if you want to be very technical about it. Right, another way to say this, which is kind of more the way a human would say this, is I would expect wages to be $4.52 lower for a female than for a man. So that's how we would interpret a dummy variable. Again, we're not doing this, an additional unit of the independent variable would lead to a B3 unit change in the dependent variable, because that doesn't really make sense. You can't be, you can't get an additional unit of gender, right? You can't become 1 unit more female or 1 unit less female. So we have to interpret it referencing those groups that we left out. In this case, the male would be the reference group, or you otherwise, depending on how you've set up your survey, if you have more options for your sex or gender, however you're coding this, if you have more options, then you'd have to make some adjustments there. All right, but this is our dummy variables. All right, we can also look at the estimated value for beta 4, so B4. I'm not going to write this one up here, but B4 is negative 1.96. That's tied to our variable black. So if we were to interpret B4, what we would be looking at is something along the lines of, again, all else equal, I would expect wages to be $1.96 lower for an individual who is black than for an individual who is not black. Again, using that reference, right? You can't be one more unit of a race, right? Or one less unit of a race, right? You're just in that category. So again, just comparing to the reference group. All right, so we're not quite done with our categorical variables. That is the basics. Everything else that applies, really the only difference between a coefficient that's attached to a categorical variable and a coefficient that's attached to a quantitative variable is the interpretation. Testing is going to be done the exact same way, right? We're going to get a standard error for our coefficient. We can test the effects, right? We can do all of that same stuff. Really, again, the only difference is that with those tests, or with the interpretation, right, we have to use that idea of referencing the group that's left out, right, rather than talking about that 1 unit increase in our independent variable. Right, so now we're going to continue talking about these categorical variables, right, because in that case, right, both of the categorical variables we looked at were presented as binary variables, right? There's 2 choices, right? We kind of defined our female as male, or kind of our sex variable as male and female. Those were the 2 options that could be chosen in that variable for the CPS data in general. And then we defined black as 1 if black, 0 if otherwise, again, kind of creating that that binary variable. All right, but what if we have a categorical variable that has more than 2 outcomes? Right, how are we going to include that into our model? All right, so for example, the CPS data that we are basing our calculations off of has a region variable. And this region variable has 4 outcomes: Northeast, Midwest, South, and West. Now we might want to include this in our model, right? We might say, well, we think that it might, wages might differ based on region, right? And there's reason to believe this, right? Cost of living differences, right? You can see that generally I would say, just speaking for the South, right? If we're comparing the South and the Northeast, the South is generally not as wealthy, right? We don't have as much money. Average incomes, average wages are lower in general in the South than they are in other places, partially due to higher costs of living. So maybe there's going to be a difference there, right? Maybe there's a difference in some of these. All right, so we want to include this in our model, but if we use the approach that we used last time for our categorical variables for our dummy variables, we're not going to be able to do that, right? Because we can't split this into 2 groups. So what we're going to do when we have a categorical variable with more than 2 outcomes is we're going to create a number of dummy variables that is 1 less than the number of outcomes. All right, so for example, here we've got 4 outcomes for our categorical variable. We need to make 3 dummy variables. All right, the reason we're making 3 and not 4 is because we have to leave one of these groups out. All right, this is what's known as, again, kind of already mentioned this, the base level variable. All right, that base level variable is what we're going to compare we're going to use to reference, right? We're going to reference that base level variable when we when we interpret our coefficients, right? So whichever one we leave out, I'll just go ahead and say we're going to leave northeast out. So when we leave northeast out, when we're interpreting, say, the coefficient that is associated with what's going to be our dummy variable for south, right? We're going to say, I would expect wages to be higher, to be this much higher in the south than in the northeast, or what's more likely, I expect wages to be this much lower in the south compared to the northeast. All right, again, referencing that base level variable. All right, so when we go to make these, creating these dummy variables is going to be pretty much the exact same as what we just saw. So we're going to leave out northeast. All right, so we're leaving out northeast as our base level variable, and then we're going to create our dummy variables, right? We're going to have one dummy variable that is Midwest, where 1 if the individual lives in the Midwest, and 0 if otherwise. We're also going to have categorical variable south, 1 if the individual lives in the south, 0 if otherwise. And finally, we're also going to include the variable west, 1 if the person lives in the west, 0 if otherwise. All right, so let's look at what this will look like for our model, and then we will pop up the estimated regression equation. Sounds like they are running a chainsaw outside my apartment, so apologies if that gets picked up on the audio. Not that this is particularly excellent audio quality, but regardless. All right, so here is our model. All right, so now it's getting a little unwieldy. That can happen if you start adding variables. These models can get really long. The regression equations can get very long. That's okay. That's not necessarily a bad thing. At this point, we might want to, take a little closer look at that adjusted R-squared when we get those results, because we are adding a lot. We have a very large sample size, so it's not going to become an issue. But once we start adding more of these variables, maybe glance at it, compare it to the just regular R-squared. If there's a huge difference, maybe look into that a little bit. But regardless, so here we have it. Wage is a function of our constant plus beta 1 times education I plus beta 2 experience I, plus beta 3 female, beta 4 black, and then our 3 regional dummy variables, beta 5 Midwest plus beta 6 South I plus beta 7 West I, and then of course we've got our error term. All right, so once we've got that model and we have our data, we can go ahead and run that regression. So here is our estimated regression equation. Wage I hat equals negative 10.13 plus 2.17 times education I plus 0.15 times experience I minus 4.50 female I minus 1.74 times black I minus 2.57 times Midwest I minus 0.76 South I plus 0.89 West I. All right, that is our model, right? This is our estimated equation. So again, these are going to be interpreted essentially the same as our previous two categorical variables, or our previous two dummy variables. One distinction though is that we will be using the same reference group for all three of these regional variables. So when we interpret Midwest, we're going to reference our base level variable, Northeast. When we interpret South, we're going to use our base level group, our base level variable, which is Northeast, right? So if we were to interpret B5, right? B5, we would say something along the lines of, I would expect wages to be $2.57 lower in the Midwest than in the Northeast, right? If I move to this last one, I would expect wages to be 89 cents higher in the West than in the Northeast. And for the South, right, I would expect wages to be 76 cents less in the South than in the Northeast. All right, so again, referencing that base level variable for all three of those regional dummy variables. All right, one thing I will note, just because y'all aren't necessarily going to see this, you might, and if I use the same data to make this kind of the mini tab video. But these three aren't really significant. I think one of them might have been significant at, say, the 10% level, but south and west were just not significant at all. So these maybe wouldn't get re-included in another go at the model, right? And in fact, going forward, we're going to do something else here in a second. We're not going to include them in the model again because space reasons, essentially, but also because they're insignificant. All right, so this next thing we're going to talk about, this is not something that's going to show up on an assignment. It's not going to show up on the test, but it is something that's interesting, and I want to at least briefly talk about it with you. Hopefully we won't spend too much time on it, but those are interaction variables. Now, what these do is they allow us to see the effect of the interaction variable, see the effect of an interaction between two variables. So for example, all right, if we consider our model that we've been working with, right, we're predicting wages, we're using education, experience, then we've got our two dummy variables, right, for female and for black, right? So our variable for female is hopefully going to give us the effect on wages for being a female, right? The coefficient on our variable black is hopefully going to give us the effect on wages of being black. All right, but let's say we wanted to see the effect of being female and black. All right, in that case, we would turn to an interaction variable. Right, and what we're literally doing is we're just multiplying the two variables together. Right, so when we create this variable, this interaction term, female times black, right, the only way the outcome is going to be 1 is if the individual is both a female, so getting a 1 in the female spot, and black, getting a 1 in the black variable, so 1 times 1 equals 1. If it's any other combination, right, somebody who's not female, but they are black, right, that's going to be 0 times 1, so 0, right? Someone who is neither female nor black, obviously that's going to be 0, right? Someone that is female but not black, again, that's going to be 0. So alright, so our interaction variable, our interaction term, female times black, is going to equal 1 if we're talking about a black female, and 0 if otherwise. Alright, we're going to include this in our model just like any other variable. In the interest of time, I think you've seen me write enough models out. I'm just going to write the estimated equation. here is our estimated equation. Looks like I also took out experience. I kind of forgot until I just saw that. All right, but this is our estimated equation, right? We're not going to read it out. But again, so we've got this term for female, we've got this term for black, and we've got this term for black females, right? The interaction term. Now, when we, and this is one of the reasons that we're not going to include this on the test or homeworks or anything. One is just slightly complicated. Your book doesn't really go into it at all. But also when we go to interpret these interaction terms, it gets a little bit trickier, right? Because to know the effect of being really anything, we have to include all of these different terms. All right, so what do we mean by this? All right, so let's think about, all right, just identifying, you know, what the effect of being a black female is, right? That's what we set out to do, so let's do that first, all right? So we might be tempted to come and look at this 3.8 and say, you know, all else equal, I would expect a black female's wages to be $3.48 higher than someone who is not a black female, all right? But that wouldn't be correct, because you also are going to kind of check the box for this female variable and check the box for this black variable, all right? And those have negative effects to them, right? So really what this is more of a counterweight for kind of double dipping in those previous two categories. All right, so let's look at how we would actually determine, right, what kind of that effect on wages is. All right, one thing when we're doing this, we can just go ahead and not worry about beta naught and beta 1 because beta naught's not going to change no matter what, or B naught, that's not going to change. It is a constant. It is going to be the same value no matter what. So changing between these combinations of sex and race, I'm not going to see a difference. All right, also we're again assuming all else equal, so the education effect, right, we don't need to worry about that. So when we're looking at kind of the effect on wages for being a black female, right, we're going to look, right, we're going to say, well, when we do this, this female is going to be a 1, so we're going to have minus 4.785, right? This black eye is going to be 1, so minus 4.17, and then you're going to have a 1 here for black times, or female times black, so plus 3.84. All right, so depending on how you round this, you might get either negative 5.12 or negative 5.11, all right? But that is the effect on wages, right? Now, of course, we're talking about dummy variables, so there's going to be a reference group. In this case, the reference group would be white males or non-black males, but most of the time we're going to interpret that as white males, all right? Maybe unfairly, but regardless, right? That's what we're going to go with, just for ease of interpretation, right? But we could say something along the lines of, I would expect a black female to have wages that are $5.12 lower than a white male, right? But again, we have to take into account all of kind of these segments, right? If we want to look at kind of some of the other things, kind of make some of the other comparisons, let's say that we want to say, well, what's the comparison between a white female and a black female? All right. Once again, we can just kind of go to this. So this is right, the effect for being a black female. For a white female, we we would do much the same kind of calculation, right? We're gonna check this box, so negative 4.785, right? We're not going to check this box, so that doesn't get included, and we're not going to hit this one, so that's not going to get included. So for white females, the kind of effect is just that $4.70 for 4.785. So if we look at the difference, right, we'd have to calculate both of those and then look at the difference to see what is the difference between wages for white females and black females, right? If we look at this, according to my notes, white females can expect to have wages that are 33 cents higher than black females. All right, again, when we're doing these, all right, the value we get just from kind of running through the calculation, that's into the reference group that is white males. If you want to make any other comparisons, then you have to find that value and then kind of here, subtract them from each other. That's essentially what you would have to do. All right, and then additionally, then just for black males are expected to make 95 cents more than black females, right? Again, we would find that by doing a very similar process, right? So female would not be included, but this 417, right? This negative $4.17 would be. The 3.84 would not be, because that would be 0. So we're looking at the difference between negative 4.17 and negative 5.12, right? And the difference there is that 95 cents. All right, again, a little bit more complicated. That's why this is just more an extra thing. All right, but those are interactions, variables, interaction terms, and that's how we use them. All right, the last thing that we're going to talk about in this chapter are some pitfalls in regression. So there are a couple of things that you want to look out for. We're not going to go into these into great detail, but all right, they are important. All right, the first is multicollinearity. All right, so multicollinearity occurs when independents are highly correlated with each other. You've got two variables that kind of move together, either positively or negatively, or kind of an inverse relationship. Regardless, when you have high levels of correlation between your independent variables, that's going to cause some problems. All right, in the most extreme case, where we have perfect correlation, right? So your correlation either equals 1 or -1, then we cannot actually perform the least squares method, right? We can't actually estimate the equation. If you try to do it in a computer software, it's going to just give you an error, right? We're not going to really get into why this is. That's kind of beyond the scope of this class. But essentially it takes the variance term for your B's, and it makes them either extremely large or it makes it where you're dividing by 0. Again, that's not necessarily important. The important thing is that if we have exact correlation or perfect correlation between two variables, we literally mathematically cannot estimate the equation. Right? In the more common case, where we just have high levels of correlation between two of our independent variables, we'll still be able to estimate the model. However, that high correlation is going to increase the variance and increase the error in our estimates, and that's going to give us estimates that are not as precise as we would want, right? And so if you have two independent variables that are highly correlated, right, probably the best thing to do is just take one of them out. If you just absolutely can't, then you're going to have to figure out a way to work around that. I believe there are ways to work around that, but at the top, I couldn't tell you off the top of my head. Also, that's beyond the scope of this course as well, right? Probably the easiest thing would just to be take one of them out. If they move in the same direction, they're probably going to be telling you the same kinds of things, right? If they move at the same time, they're probably going to tell you the same kind of things, all right? But we can create a correlation matrix in something like Minitab or Excel, right? Just see those correlations for our independent variables to check to see if that might be a problem. All right, the next thing we're going to talk about is parameter estimability. All right, so again, this kind of comes down to the mathematics of it. And the long and the short of it, I have a whole thing I could write down, but I'm just going to write this down, all right? In order for us to actually be able to estimate our parameters, right, to actually get numbers, our sample size has to be at least one larger than our independent variables, right? If we have more independent variables than we do have observations, we're not going to be able to actually estimate those parameters, right? So this has to be the case. This should be the case anyways, right? Usually you're going to have way more observations than independent variables, but if you ever find yourself in a situation where that's not quite true, right? You have to have at least one more observation than independent variable to be able to estimate that equation. All right, the final pitfall is extrapolation, right? When we are doing regressions, right? When we're doing a simple regression, multiple regression, whatever, right? The main object is to be able to predict the dependent variable, right? But when we do that interpretation, right, or when we do that prediction, we need to contain our values that we plug in to values that were in the data set we used to estimate it, right? So all right, so the estimated equation only predicts values within the range of the data with validity. All right, so what do we mean by this? All right, if we're looking at our wage equation and we've got, let's say that our data on education, the values range from 0 to, which would be very unlikely, you probably at least have to get to 6 or something, regardless. Let's say 0 to I don't know, maybe 18, and that's probably maybe 22, that might be the highest we go. If we plug a value for 37 in there, right, a value outside of the range of the data, right, then we are kind of extrapolating, right? We're saying, well, this relationship, we're assuming the relationship maintains, all right? And that's not necessarily true, right? Again, if we plug in a value for experience, years of experience that is outside of the range of the data that we use to predict the model, right? Once again, we're going to be extrapolating, right? And our results aren't guaranteed to be valid, right? So we need to stick within kind of the confines of the data we used to estimate the equation. All right, that is it for this chapter. We may or may not have more of this. It kind of depends on how the semester is going, depending on when you see this. So we may or may not see you in the next video.